Is it anytime? Okay. Let me know when they're recording. Okay. Okay, you guys all set? You ready to go? Okay. Thank you very much for coming this afternoon. We really appreciate it. I'm Charlie Jett. I teach math and science 7th grade here at Briggs. And with us here today are some of my students. And I don't want to steal their thunder because they're really going to present everything, the reason why we're here this afternoon. But it's been a fantastic year for science here at Briggs. I was fortunate enough to be part of an Oregon Department of Education grant where we got a lot of data collection materials to do science inquiry. And rather than go too far with that, because again they're going to speak, we were able to use the technology we got from the grant to investigate a real-world problem. And with that, I will turn it over to my 7th grade students.
Thank you everyone for coming and taking the time to watch our presentation on the temperature CO2 data that Mr. Jett's math and science classes have collected.
Here presenting today is myself, Riley,
Ashley,
Leanna, Kaylin, Bertha.
I'm Hannah.
I'm Perry.
The science inquiry project that we conducted was possible because Mr. Jett put in for the Oregon Department of Education TED grant.
And without this grant, we don't think that it'd be possible to do some of the labs that we do today with the Vernier data collection lab quest sensors and probes to do hands-on experience labs. And the labs that we do with this technology, we do better labs than we could do without them.
Teachers and students first realized the heating issue on December 9th, 2011, when the 7th grade quad, which is a cluster of 4 rooms in one designated area, was over 90 degrees Fahrenheit. And as you can see on the lab quest in the picture, it says 90.9 degrees Fahrenheit, and some students were sitting on the floor because hot air rises and it was cooler near the ground.
This graph was taken on March 1st by 2 of our students. This is when we noticed that this is when we came in and there was a second spike, and this is from Mr. Jett's room all the way back down to the office, and up here is 92 degrees, and then still down here it's the lowest it goes to the low 70s, high 70s, but this is from the 8th grade quad going up into Mr. Jett's room, and this is initially when we realized we should start the inquiry that we were doing, and this is just one of the many graphs that we have taken.
We thought that this would be a good opportunity to do a science inquiry project that was worthwhile and we could change something.
It was also to practice the scientific method that Mr. Jett taught us and to improve our school environment and our student learning as well. And the carbon dioxide sensors were added to the study because we already had them and because people have been complaining of thick air in the school.
So as we are going through our research and our data collection, we wanted to make sure that all of what we were saying to each other and that our lab quests were okay to use and that our information was relevant in the actual world and other people's minds. So John Wiley did a study, and he had wrote that elevated or high temperatures produce negative moods and poor work ethic. And we also found that Wisconsin Department of Health had stated that carbon dioxide levels over 1,000 parts per million in a room can cause drowsiness. But it wasn't just Wisconsin Department of Health. We also found it in the Environmental Protection Agency. So as we're using our Vernier lab quests and our temperature probes and our carbon dioxide probes, we wanted to make sure that those things were good enough to use, that they weren't above or negatively better than we wanted it to be. So our Vernier lab quests are excellent for student visualizing data. So visualizing as in seeing when like our temperature, our carbon dioxide rises at each time. And our vernier temperature probes are accurate to plus or minus 1/100th degrees of Celsius or Fahrenheit. And our vernier carbon dioxide sensors are accurate to plus or minus 100 parts per million. So if you think about it, 100 isn't that much. For example, if it was 1,300 parts per million, if you add 100, that would still be 1,400. And if you subtracted 100, that would be 1,200. So thinking about all of this, we wanted to state that if a temperature in a classroom at Briggs Middle School is over 76, 75, we thought around 75, 76 degrees was high, because around that we started getting emails stating that it was hot in the rooms. And then student learning will be negatively affected because heat can affect mood and work ethic.
Okay, so for CO2, we took the sensors, and if we took the reading and the carbon dioxide level was over 1,000 parts per million, then student learning could be decreased and they could begin getting drowsy, so they wouldn't be able to learn as thoroughly as they would if the CO2 level was lower. So previously you've seen or heard the students talking about the Vernier Lab Quest, carbon dioxide, and temperature probes. And so I just wanted to show you what those look like, and they're right here. And currently we are taking readings, and the temperature in this room right now is 78.7 degrees Fahrenheit, and the CO2 level is 650 parts per million.
Okay, so between March 5th and April 5th of 2012 this year, teams of two of Mr. Jet's AM and PM students recorded temperature and carbon dioxide, which is CO2 readings, twice a day, and sometimes 3 times daily. And then, so like to prove to you that we weren't lying, we had the current teacher in the room sign off on where we wrote our data next to the data, to prove that, you know, the data is hardcore and they're looking at it on the Vernier Lab Quest. And about 5-6 days in, 6 rooms got Nomad digital thermometers installed, and we just kind of wanted to thank you, because, you know, that tells us that you're paying attention and that you actually care, and so we're just like thanking that. And then so we had those readings recorded at the same time along with the Vernier readings.
Okay, so we took quantitative and qualitative data. So the quantitative would be the numbers that we're recording from the data so that we can enter them into spreadsheets later, which will be shown in the next slide. And then qualitative data, like were the windows open, were the lights on or off, were there any students in the classroom? And so we knew that if there were students in the classroom, then there would be more CO2 in the room, because that's what students are breathing out, and so that could affect our CO2 readings.
Okay, so here's some of that quantitative data we were talking about. Yellow was midday around 11 o'clock, and we didn't really have a class then, so we had students volunteering if you see numbers in there. And so students volunteered, and then the black is Oaks testing. Either we ourselves were testing and could not get to those classrooms, or the room was testing, so it was locked. And then up here we have not available, which means that the room was just locked up. Maybe the teacher had been stepped out for a second, got to the computer lab, any excuse for them to get out of the room. And then we have the red missing, which we got marked down for that in our grade, because that means that we did not get data in when we should have. But we still managed to get a few good numbers here. And then, so in the red, if you can notice it, we have really high numbers that we thought would be a good thing to be popping out, and then actually right here we have a 79 degree Fahrenheit in just room 10.
This is another graph, but for carbon dioxide, and so you can see that there's blue here, and that is the days that we decided that we should go outside and recalibrate the sensors because we didn't want to get crazy readings and have like crazy numbers that are going all over the place that aren't real. And so here in purple and there's some in pink there, we're not sure about those because they don't really fit in with the other ones and they're not like around the same number range. And still there's yellow there because students weren't able to get in at that time, and Oaks testing.
The analysis is basically when we started creating, like when we looked at all of our data and saw what we found. Our second assignment that we did and got graded on was we got together with our partners and we created a paper which they're spread out along some of the tables, and we calculated the range, mean, median, and mode, and graphed temp CO2 using Google Charts, which, yeah. And then later we presented our findings to the teachers, which in turn also got us here to the point to where we are presenting to everyone here. And then our fourth assignment, which we did a whole school analysis, which is where we took mainly the problematic rooms that we had found, and we put them all in a final report, which some of those are spread out on the tables as well. And each student had a choice between one of these, and when they chose that, that's what they did, and they had to contribute to that to put it into the report. And then at the end, we put all of our sections in a paper and combine them to make one big school-wide temp CO2 study. So then I already talked about that. The data showed that there were elevated temperatures in several areas of the building, mostly the 8th grade quad though, but not always. And there were not really any noticeable trends. It was just every once in a while. And then we also noticed that the district installed nomad digital thermometers in 6 rooms, consistently registered -2 degrees compared to our Vernier LabQuest. That was just probably because of the placement. They're placed on usually cold cinder blocks right above air return vent, so you could see why it would be -2.
We also did the same thing with CO2, which is carbon dioxide, and the data that we had collected from the rooms with high CO2 levels were mostly the 8th grade quad, but other classrooms also were affected. And the elevated CO2 levels possibly may have not been CO2, but other particles in the air. This is the carbon dioxide graph that shows 3 rooms, 3 problematic rooms that, as you can see, go higher than 1,000 parts per million, and compared to the outside CO2 level. And the outside CO2 level stays around 400 parts per million and raises to about 600, which is more comfortable and healthy. Room 11 ranged from 515 to 1520 parts per million. Room 12 ranged from 412 to 1360, and room 10 ranged from 470 to 1750. This is the temperature graph that displays a room with comfortable levels to 2 different rooms with higher levels. The 2 uncomfortable rooms were both 8th grade rooms, and the orange one is the 6th grade room, and room 10, which was one of the 8th grade rooms, was much warmer, and it ranged, the temperature ranged from 71 degrees Fahrenheit to 79 degrees, and room 9 ranged from 70.9 degrees to 76.9 degrees, and room 3, being lower and a little bit more comfortable, ranged from 67 degrees to 71.7 degrees.
So the 8th grade quad, in conclusion, has been the most affected in Briggs and has a very highly elevated CO2 levels, but only occasionally high temperature ratings.
The 8th grade quad isn't just the most affected. A lot of other classrooms were affected too.
We suggest that the teachers open doors and windows if they have them, and if possible, to let out some of the CO2 ratings, and to also let out some of the heat as well.
We also suggest that if the carbon dioxide problem still continues, that we have the building maintenance come in and clean out the air vents and inspect them for any problems.
We think that there could also be a follow-up study conducted to make sure that the air quality is still at the regional rate. You know, maybe Mr. Jett's 7th grade class could follow up yearly, once a year, with his technology. And then maybe if a few more other classes get technology, then they can jump in it too and compare ratings.
We may have the chance to replicate this study with the U of O Architecture School for future environmental studies, and so like they can build buildings and maybe come back and see if there are any problems with them instead of just leaving them and assuming that they're okay.
A couple days after we finished our study, we noticed that district facility vans were outside, and we've heard that you guys have been fixing the problem, so thank you.
So as of May 23rd, which was just last week, we took another CO2 reading in Mr. Jett's room, and it came only to 575 parts per million. So it went down a lot from what it had been, so we are very excited and wanted to say thank you for that too.
And we just want to say thank you for listening to our presentation and for taking the time to come out of your day, and for supporting student science inquiry projects like this, because it could be very helpful in the future.
Concluding with what Ashley has said, we also noticed one afternoon when we were in PM Core that there was a guy working on the temperature in our specific classroom, which was one of the ones that had an elevated temperature, so another thank you.
We just really hope we've helped, so thanks again.
Does anybody have any questions?
So what was the experience like this is a science class, and it seems like you learned a lot of important concepts. How did you like the experience, and why?
I personally really enjoyed it because it helped me like learn things that I would have never even imagined to. Like, I didn't even think that coming into 7th grade I would do anything like this. I thought we would just walk in, read a book, put our heads on the desk.
Okay, well, I'm just going to come out and say it. I never even knew the Vernier LabQuest stuff even existed. So I'm happy that I got to experience that and get to know more technology, and hopefully we'll get even more in the future.
And then, you know, for me personally, it's like I don't have a lot of technology at home. I'm kind of on the poor side, so we can't afford that stuff, you know. I don't go on the internet a lot. And in this class alone, I have gone on the internet and learned more about technology than I would have in a lifetime without this stuff.
How many of you guys feel like a scientist when you were doing this work?
I think we all did. Our classmates who are not here could have agreed.
We have other students here
Some back there.
who,
Yeah.
they are free to chime in as well anytime.
Cool. And do any of you think about going and studying science when you get out of high school? Does it kind of make you think differently?
Yeah.
Yeah.
Thank you.
I was able to kind of browse in Google Documents and see that there were some kids who were working at night, like 7:20 at night. I could see that there were students working. How much more or less did you work on a project like this compared to, say, science class last year or other classes this year?
I think we worked a lot harder because, we care about the environment, we care about our school. So we're just on it anytime, you can access Google Docs from home, you can access it from school. Anytime you can get on the internet, you can get this and just work. It's not like a moldy bread study where you can only do it in a room and you can't take it with you. And it's like, stuff like that is observation. This is quantitative and qualitative data. So we're all pushing hard for it and just trying to make a difference.
And then one follow-up, you collaborated on your document. I noticed your writing was quite good. Could you talk about the writing process?
Okay, so we did it with the scientific method. So we wanted to focus more on purpose, research, hypothesis, methodology, conclusion, recommendations. But we wanted to put more and more effort into it to make it like college, high school work. We wanted to make it as best as we possibly could and not look back with a regret that we didn't write it with our best possible.
We tried to make it look as professional as possible. We were trying to make it just so when someone reads it, they can understand it and it makes sense and it looks good too, all at the same time.
And another thing that we recently found out is this study, the middle school study, is actually being published. So that just made our work even more important to us because, we worked hard, we looked in books, we researched on the internet, we did anything we could to get that writing to sound professional.
How does it make you feel knowing that the school has been having this problem for a while now?
Me personally, it made me feel bad, there's students who go through here and they could be getting the highest level education, but with this problem, they're just not absorbing it all because they're too focused on, it's hot in here, I need to get out of here, what can I do to cool down, instead of learning the actual thing. So it made us feel bad. But then when we realized there was something we could do to help it, I think it boosted all of our spirits that we could, make a difference like this.
But now we are also being helped, so we don't really have to worry about that problem as much anymore.
Are there any more questions?
Do you think a study like this would lead you to asking other questions about your school environment?
Definitely.
Definitely. Me personally, I hear about this problem, and it's like you go through it and you're thinking, it's what else is there that we can fix?
Can I add to this? Is there an opportunity in these last 2 weeks of school for follow-up study? Do students have the option?
Yeah.
Yes.
What is that opportunity?
We're doing a final experiment where we have to make our own experiment and do whatever we want. So we could do anything from throwing airplanes to see which one flies farthest to following up this. It's amazing how much technology we have that we can do so much experiments with stuff we didn't even know about.
Any more questions?
Were there any hiccups along the way?
Quite a few.
Oh yes, there were a lot of problems we encountered, but as a class and with Mr. Jett's help, we honestly just bound together and we're like, we can get through this.
I have a question. This was a month long, right? Just so people understand. Were you just focusing on this daily whole science periods while you were collecting data?
No.
What was
We did it
how long did it take to collect data daily?
about
15 minutes.
15 minutes between both
And
classes.
then 5 to 10 minutes to put the data into bullet charts that we had made.
And then we went on to other content, right?
Yeah.
So, okay, good.
When you took CO2 readings in classes, did you also make a note of how many students were in the class?
Yes, that
Yeah.
was part of our qualitative data. You know, we went through, we count the students, we look at windows, make sure we got everything down and see if it was consistent with people. You know, some days there's 25 kids and then the next day there's a few absent and then it goes down.
Were you taking the readings just at a certain location every day? Did you move around? Were you taking them, did you take them at some
We
point
had
closer
certain-
to
yeah.
the supplier
Each kid had
coming
a
in?
certain.
Well,
We had
we
certain
teamed
rooms
up with
assigned to us.
partners, and we got to choose our partners, but we wanted it to be a partner that we could work very well with to do our very best.
I think the question is, did you stand in the same place in the room? Were you in the same
No.
area? Did you go to different areas of the
We tried
room
to
where the
move
vents were?
around. It helped that we moved around so we could just get all areas of the room, so we did, that way it wasn't just one spot, say, it, like a ton of kids in one area and there's a little over here. If you go over there, it might be a little bit lower CO2 and it might be heavier over here. The temperature might be hotter over here than it would be over there, so it just varied.
You also had to not disrupt class, because there were classes going on. You did this for a month, so.
But would it be fair to say that you and your teammate, always went back to the same, you were assigned to a certain classroom?
Yes.
So you always went back to that room for the entire month? And you
Yeah.
were in charge of that data?
Yes.
Yes.
Like 2 or 3 rooms.
So
Some
that's
had 4.
so that's the reason why you saw a couple missing on there, because some
It gets
Groups.
overwhelming sometimes.
some groups just didn't want to put the data in that day.
And then we actually had not only the 2 spreadsheets that were up there, but we had our own individual team spreadsheets that we actually had a slot where we had to put in what we were recording, where we stood in the room, how many students, anything that we thought was important that needed to be on there.
Did you learn anything new throughout the project?
I think we learned a lot of stuff. We learned that there are many different ways to take readings, and that we learned more about Google spreadsheets and how to operate those. And we learned so much, I just can't even begin to explain.
I'm curious to know what you guys would like to do for an 8th grade science project.
Where's some ideas kicking around for the final project?
Maybe looking at the water supply and see how good the water is here at Briggs.
Compared to the compared to the water at your house or water you could buy at a store, see the differences between the 2 or 3.
Now that you're done with this project, are you proud of yourself?
Yeah.
Yeah.
Are you proud, Mika?
I am.
The paper show.
These are my other students who are also asking questions, so yes. They also collected data and wrote terrific sections of these reports, so.
So if we wanted to know more about the problem classrooms, we could get an in-depth.
Yes, they are the investigators, they have the
Okay.
data for their rooms, yes.
Any more questions?
Thank you very, very much again, and as you feel free to ask them as you depart, and you can take a look at the reports. Great. You can look at the Vernier LabQuest